Hello, this is Mr. Best. Welcome to Chapter 9, homework questions 6 through 11. Question 6. Use your generalized process of completing the square to rewrite and solve each quadratic equation below. So to be able to do these, we can look at the completing the square process either using a generic rectangle, or we could potentially draw out the algebra tiles to help us out. Either one is perfectly fine. On part A, we have w squared plus 28w plus 52 is equal to 0. So I'm going to use the generic rectangle on this first one. So we know this is w squared. If we have 28 w's, we need to split those up into 14 and 14 on each side. So that means we have w plus 14 on each side. So that's the square. There are currently 52 tiles, but how many do we need to complete the square? Well, we need 14 times 14, which is 196. So we are definitely short. So we need to add 144 more tiles. So we have w plus 14 squared, because that's the square part. We need to add 142 more tiles. No, 100. What did I say? 144. 144 more tiles. So therefore, this is equal to 144. Because this side was 0. So we had to add 144 to complete the square. So we have to add 144 to the other side. So now we can solve this by setting up the square root of both sides. So that is the absolute value of w plus 14 is equal to the square root of 144. And that is a perfect square. So that is 12. And so now we can set up our two equations. So w plus 14 could equal negative 12. Remember, the absolute value is the distance from 0. Or it could equal a positive 12. And so it looks like we get a value of negative 26 and of negative 2. So those would be our solutions to the quadratic equation by completing the square. So you could say w equals negative 26 or w equals negative 2, or we can put it in a set such as that. Either one is fine. So that's how you can use completing the square to be able to solve. Let's go ahead and look at B. So B, we have x squared plus 5x plus 4 equals 0. So on this one with the generic rectangle, we have our x squared. But 5x to be able to split in half, that's going to be 2.5x. Okay, and so this is going to be x plus 2.5 as our square. And then we have this plus 4 right here. So that's what's there right now. But if we take 2.5 times 2.5, that's going to give us 6.25. So what do we need to add to get to 6.25? We currently have 4, so we need to add 2.25 to the other side so that we keep it balanced by adding the 2.25 to this side. So that gives us x plus 2.5 squared is equal to 2.25. And now we can take the square root, which gives us x plus 2.5. Whoops, that's the absolute value. Is equal to the square root of 2.25. So that's the absolute value of x plus 2.5 is equal to the square root, which is 1.5. And so now we can separate into our two equations, where inside the absolute value could equal negative 1.5, or inside the absolute value could equal positive 1.5. Once again, the distance is both being 1.5 away from 0. And so we get x equals, subtract 2.5, so x equals negative 4. And then subtract 2.5 to the other side and get x equals negative 1. So x equals negative 4 or x equals negative 1, or once again we can write it as a set. Alright, moving on to C. We have k squared minus 16k minus 17 is equal to 0. So here we go, once again setting up our generic rectangle to help us out. So to split the negative 16, we need to split that into negative 8 and negative 8. And so that means our side lengths would be k minus 8 for both of them. So right now we have negative 17 one tiles, but negative 8 times negative 8 would be 64. That's what we need on that side. So right now we have negative, so you need to have 64 total, but you have negative 17 right now, so you need to add 64 to your negative, or to your 17 actually, to get the total. Right now this is equal to 0, so you need to add 17 tiles just to get it back to 0, and then add another 64, so that would be 81. So if you added 81, that would give you your 64 that you need to complete the square. So now we have k minus 8 squared is equal to 81. Take the square root of both sides, so that's the absolute value of k minus 8 is equal to the square root of 81, and that's the absolute value is equal to the square root of 81, which is 9. And so once again, there's two values that give you, so when you square something, there's two numbers that can give you the same thing. So for example, negative 3 squared, the quantity is 9, and 3 squared is 9. So that's why we need the absolute values, absolute value symbol. So k is minus 8 could equal negative 9, or k minus 8 could equal positive 9. Once again, there's two distances that would give you 9, and so therefore k, when you add 8, could be negative 1, or when you add 8, you could get 17. So k equals negative 1, or k equals 17. Or once again, you can use and plug it into a set there. All right, on to the next one. I have to move down a little bit here, but D, we have z squared minus 1000 z plus 60,775. So we've got some bigger numbers here, but the idea still applies. You have your z squared, and then 1,000, that's going to be 500 on each side. So that's z minus 500. And so right now we currently have in here 60,775. But we need negative 500 times negative 500 tiles, so that would actually, we need 250,000. So how many in addition do we need? We already have 6,000, we already have 60,775. So if we already have that, then we only, take the difference of those to see how many more we will need. And if we do that, we get a value of 189,225. So that'll leave us with z minus 500 squared is equal to 189,225. So if we take the square root of both sides, we get z minus 500 is equal to the square root of 189,225. And so when we take the square root of that, we have z minus 500. The absolute value is equal to 435. And then now we can set up our two distances here. Z minus 500 could equal negative 435, or z minus 500 could equal positive 435. So if you add 500 to 435, you get 65. So z is equal to 65. If you add 500 to 435, you get 935. So these are the two answers that z could be. So z could equal 65, or it could equal 935. So that's how you're able to solve quadratic equations by completing the square. All right, moving on to question number 7. For each of the following equations, indicate whether its graph would be a line or a parabola. So when we're looking at this, we're just identifying what it could be. On part A, this is something that could be written in the form of y equals mx plus b. You can see your x variable has an exponent of 1, so it's not a parabola. That would be squared, so we know this would be linear. For example, A. B, you have that x squared right there, and so that's what makes it a parabola. And I guess it's asking whether it's a line or a parabola, so I'll change that. We'll say this is going to be a line. This one will be a parabola. C, y equals 3. You don't see the x value, but that would be y equals 3 plus 0x because your slope is 0, so this is also a line. And on the last one, you can see you have your x squared once again, so that would represent a parabola. Question 9-8, multiple choice. Which equations below are equivalent to that equation right there? And so I guess what we need to do is simplify the equations and see if they represent the same thing. So let's go ahead and distribute the 1/2 here. This would be 3x minus 7 plus 5x is equal to 2 minus 3x plus 8. So does that one appear anywhere on here? 3x minus 7 plus 5x. It has 10 minus 3x. Well, if you simplify the right-handed side of the equation, this would be 2 plus 8 is 10 minus 3x. So it does appear that in part A, those are equivalent. On the next one, we have 3x minus 14 plus 5x is equal to 2 minus 3 plus 8. That wouldn't be right because that would be similar to this one right here, but it has minus 14 instead of minus 7, so that one's out. Let's go ahead and simplify. 3x plus 5x is 8x minus 7, and then we still have the 10 minus 3x, so once again, similar to this one, but it has minus 14 again, so that one's out. And the last one, might just have to solve it to figure out. Let's take the last one, maybe simplify it a little bit here. We got 6x and 10x is 16x minus 14 is equal to negative 6x plus 20. It doesn't appear to be the same, but not really sure right now, so let's keep working this out. Let's go ahead and add 3x to both sides. So we have 11x minus 7 equals 10. Let's add the 7. And I have 11x equals 17. So let's add the 6x. It's going to give us 22x minus 14 equals 20. And then add the 14. So 22x is equal to 34. It doesn't appear to maybe be the same, but let's go ahead and finish this because this one actually is 17/11. It's already simplified, but there's a common factor in this one. So if you take 34 and divide it by 22, 34 22nds, if you divide both those by 2, that is 17/11. So it does actually work out. So which equations below are equivalent? It would be A and D. The other thing that we could do, take a little bit more time, is to actually solve all 5 of these equations and then compare our answers at the end, and those would be the ones that would be the same or equivalent. Question 9. Rewrite each radical expression in exponent form or exponent form. So exponent form just means that we're going to be writing with a base and raised to a power. So the cube root of 10 in exponent form as an exponent would be 10 to the 1/3. With the square root of 15, remember there's a 2 right there, so this would be 15 to the 1/2. On this next one, we have 18 raised to. Now the 4, just like the 2 and the 3 above, represent your denominator, and then the 3 on the outside is your numerator, so that'd be 18 to the 3/4. And then on D, a little different here. We want to maybe rewrite this before we write it as an exponent, because I guess right now as an exponent we could say 1 over 5 to the 1/2, but typically we don't want to leave that in the denominator, so we can rewrite that as 5 raised to the negative 1/2. But I think either one of those would be acceptable because this one is a negative exponent, and a lot of times we talk about wanting it a positive. So I would say either one of these would be okay. Question 10. Examine the two equations below. Where do they intersect? So because we're looking at an intersection of two lines, we're solving a system of equations. Both of them are set equal to y, so we can use the equal value method and say that 4x minus 3 is equal to 9x minus 13. And then we can go ahead and solve, subtract 4x. Negative 3 is equal to 5x minus 13, add 13. So we're trying right now to get the variable on one side and the constant on another. 10 is equal to 5x, and then divide both sides by 5, and you get x equals 2. Now we can take that and plug right back into one of the equations from above. So y is equal to 4 times 2 minus 3, which would be 8 minus 3, and that would be 5. And it doesn't matter, so I'm just going to show you real quick that if you multiply by x on the second equation, 9 times 2 minus 13, we get y equals 18 minus 13, and that is 5. So it doesn't matter which way, or which equation I should say, that you plug into. So your solution is 2, 5. Question 11. Find an equation of the sequence represented by this graph. So you're given 3 points, so I think to help us out, let's go ahead and write this in a table form where we don't have the 0, 1, 2, or 3. The first one we have is at term 4, which would be 12, 5 is 36, and 6 is 108. So do we see what's happening here? Each of these is getting multiplied by 3. So we know what the multiplier is, but we got to work backwards to at least get back to the first term so we can write it in first term form, or we can get back to the 0 to write it in 0 term, or the initial term. So let's go ahead and work backwards. 12 divided by 3 is 4. 4 divided by 3, and we want to write this as a fraction, 4/3. And then if you take 4/3 and divide it by 3, you're looking at 4/9. And then if you do it one more time, if you divide by 3, you're looking at 4/27. So you can just keep dividing by 3 to get those. I'll show you both forms. If you have t of n, that could be equal to, we'll just go ahead and use our term 0. So t of n is equal to, it starts at 4 over 27, and it gets multiplied by 3 each time, so that's raised to the n power. If you want to write it in first term form, we'll start with the first term of 4/9. Still the multiplier is 3, but then we'll raise it to the n minus 1 power. The alternative notation for this is a sub n. So you could write each of these as a sub n also. That's okay as well. So really any of those three, and you could rewrite technically this one in a sub n 4, so you could say 4 different ways to kind of write this. And it satisfies the question, because it just says find an equation of the sequence. So any of those 4 would be perfect answers for this one. And just for fun, because they did give us the fourth term and we had to work our way backwards, we have a first term form and we use term 0. Just for fun, what if we wanted to start at term 4? Could we say t of n is equal to 12 times 3, but then what power would we raise it to? When it's term 0, we raise it to the n. When it's term 1, so this is the 0 term. This is the first term. So what if it was the fourth term? What would I raise it to? And if you said n minus 4, you would be correct. So you can double check that in the table, but there's plenty of ways to write a sequence. It just depends on where you start.